I'm going to look at 2018. This one here now, 2018. Let me just see. Right, okay, so when a rusty object, so this is 2018 10C, when a rusty object was coated with phosphoric acid, all of the rust on its surface was converted to iron phosphate according to this balanced equation here. Okay, so we have iron oxide plus phosphoric acid giving you iron phosphate plus water. And it says the iron phosphate formed was found to have a mass of 4.53 grams. How many moles of iron were removed from the object? Okay, so this was the rust. This rust reacted with phosphoric acid to give you this fella here. So it's the Fe phosphate first of all that we're going to have a look at. So the iron phosphate, what's it made up of? This iron phosphate, it says how many moles of iron were removed from the object. So this is what was removed, this fella here, that's what came off. So iron phosphate contains 1 mole of iron and 1 mole of phosphate. This is what this is made up of, a 1-to-1 ratio. Phosphate, remember, is 3-, so this is +3. So 1 mole of iron phosphate will produce 1 mole of iron. And you are asked for how many moles of iron were removed from the object. Okay. It says, the iron phosphate was found to have a mass of 4.53 grams. So 4.53 grams divided by its relative molecular mass, which is 56, phosphate is 31, plus we've got 4/16 for oxygen. That gives us 4.53 over 151, which is 0.03 moles. So this iron phosphate is 0.03 moles. It's a 1-to-1 ratio, which means it will produce it contains 0.03 moles of iron. And that's all I'm asked for there. I don't have to convert it to mass or anything. So how many moles of iron were removed? 0.03 moles of iron was removed. The second bit, what mass of rust was adhering to the object before treatment? Okay, so this iron phosphate came from this rust. So 2 moles of iron phosphate came from 1 mole of rust. So 2 moles of iron phosphate came from 1 mole of rust. Question says what mass of rust was adhering to the object. Okay, so therefore 1 mole of iron phosphate came from a 1/2 mole of rust. And if I have 0.03 moles of iron phosphate, that meant it came from half of that, 0.015 moles of rust. Question says what mass of rust, so I'm going to convert that to mass by multiplying by the relative molecular mass, which is 56 by 2 for iron, plus 3/16 for oxygen, and that will give me a total 160, and when I multiply that by 0.015 I get 2.4 grams. Okay, so that's the second. Okay, so the third bit asks me what was the minimum volume in centimetres cubed of a 6 molar solution of acid needed to remove all of the rust. Okay, so let's come back to this equation here. 1 mole of rust requires 2 moles of acid. So 1 mole of rust needs 2 moles of the H3PO4. How many moles of rust did we have? So we're after finding that already. Back here we said that 0.015 moles of rust. So we've got 0.015 moles of rust was used. So we're going to have double the amount of acid required, which is 0.03 moles of acid needed. Acid is needed. Now, it says, what was the minimum volume needed? So I'm going to convert this to volume. Now, in order to convert this to volume in centimetres cubed, this is phosphoric acid is a liquid. Okay, so I can see from here, this is aqueous. This is not a gas. If it was a gas volume I would use at STP 22.4 at room temperature 24, but this is neither. It's not a gas. Phosphoric acid is a liquid, so I have to convert that number of moles to a volume in liquid. So the equation I'm going to use for that link is that the number of moles is equal to volume in litres multiplied by molarity. So the number of moles is 0.03 is equal to the volume, which is what I'm looking for, multiplied by the molarity. I'm told that it's a 6 molar phosphoric acid. So the volume in litres is going to be 0.03 over 6. And when I work that out, I get 0.005. And of course, that's litres. And just to finish off, it says, what was the volume in centimetres cubed? So I'll multiply by 1,000 to bring that to centimetres cubed, and I'll get 5 centimetres cubed. So that's the answer for that part. And the last bit, what volume of liquid water was produced in the reaction? Okay, so here's my reaction. 1 mole of rust gives me 3 moles of water. So 1 mole of rust gives 3 moles of water. And again, it's aqueous, it's a liquid, so it says volume of liquid water. Now I'm going to use a density link is given to me here in the question. Remember, density is mass over volume, so I'm going to work with this. Density equals mass over volume, and I'm told the density is 1, so that 1 is equal to mass over volume, which means the volume would be equal to the mass if I cross multiply here. Okay, right then, so come back again to how much rust did we have? We had 0.015 moles of rust. So 0.015 moles of rust will produce 3 times as much water. So 3 times 0.015, which will give me 0.045 moles of water. Now I just need to convert that then to volume, and using this link here, volume and mass are the same. So I'm going to convert that to mass. So to convert to mass, I'm going to multiply it by the relative molecular mass of water, of course, which is 18. And when I multiply 0.045 by 18, I get 0.81 grams. And using the density link, that means 0.81 grams is also equal to 0.81 centimetres cubed. So that is the volume of water produced. So this one was kind of unusual, girls, because she asked you for a lot of volumes of liquids. So you had to be careful. And you can see, in using the volume of liquids, we've used 2 different equations here. We've used this one, moles is equal to volume by molarity, and we've also used the density one, which you'd use a lot in the organic stoichiometry.